Hey, what's up? This is Rob from GetSomeSystems.com. We're going to do a demonstration of a quick graphical user interface app that I wrote up to communicate with a small embedded system. It's an FPGA Xilinx FPGA development board. And so we're going to program that real quick. Alright, here's our application. This is our graphical user interface. We're going to communicate over a serial port and control a couple things on the FPGA, and the FPGA is going to output data that's going to allow us to update our user interface to keep track of a couple things. To go over this real quick, there's a regular menu bar, toolbar, some text boxes. It's a serial input, output, records and logs all our data for our serial communications. And processing text box, it's just some debug information from developing the application, and this is a communication monitoring. And so this goes along with this gauge over here, and they're going to monitor an 8-bit value in the FPGA that's controlled by slide switches here on the front. And this hex value is also going to represent the 8-bit value that's controlled by these. And our application is going to update every second to display that to the user, so we'll know, say for instance this is a motor controller and we want to update and keep track of our motor speed or something like that. We're going to have that register output in here, just one register, and that's going to be done independently monitored here. It's not going to slow down our application at all. These buttons up here is going to start some free running timers to show how we can run multiple independent threads to do different things. This example is just going to be a timer. We're going to update every second, and each timer is going to be its own thread, and those allow us to do a couple things, a lot of things at the same time without slowing down our response time for our application here. This is just a save button. It's going to save all of our data from these text boxes into a text file. That's our open serial port button, close serial port, exit program, and this button on the end, these two kind of go together. This is going to start cycling through all our LED routines automatically, and that'll make more sense later when you see it. And this is going to stop both that LED cycling and the free running timers, all those threads. This is going to stop those. Now we can restart them, stop them, restart them, stop them. So first we're going to open up our serial port, Comm 6, opened up, no problem. And now we start logging. This is our 8-bit register. For this example, we'll just assume it's a motor control speed value or something. So it's going to display the number in different decimal systems here. It constantly refreshes. It doesn't scroll like these, so it looks a lot cleaner. And it's going to be our visual throttle gauge. It's going to show us visually these same values. And so this is just, information coming in and out of the program, mostly for debugging. This value is going to be our 8-bit value from the FPGA. This is our serial input. This is that value. This is the data that the FPGA is sending our application, and it's receiving this, processing it behind the scenes, and displaying it in a cleaner manner for the user. Here we're going to have our manual remote control of our different LED routines that you're going to see. One of them's running on the LEDs right now. We've got 4 of those. So we'll start going through those. It's just a binary counter and some other LED bouncing right here. And so obviously the point to take away is you can link that to any event in your embedded system. These are all just events, LED arrays. This is our event monitoring and our communication link. We've just got a real simple protocol. And so now we'll start our auto cycling through these routines. And you can see the commands sent, all sent automatically, 1-second increments. Here's our output. Our input's still the same because there's no response. With something this simple, there's no response from the FPGA, it's just outputting its 8-bit value there. Now we'll stop those with our stop button. And so now we'll go on to controlling this throttle value. So that's controlled on the board with these slide switches down here, and we'll start pushing this up to 255. You can see it increasing as I go up all the way to the most significant bit, turn off the most significant bit, go down to 127. You see our visual indication is modified accordingly. And so now we'll start a couple threads. We'll start our array cycling for our LEDs. You can see that's back on. And now we'll start some timing threads here. You can see free running timer thread 1, 2, 3, updates every second. So we'll start a couple of those. This will get a little busy. And our output through the serial port, it's automatically being sent. This is a thread as well, and so you can see the response from our program. We don't have any problems. And even though these timers are not communicating over our serial link, they could be. I didn't have time to write up really anything else. I just wanted to put a quick thread example so you could see you can run a lot of things at the same time, a lot of information, a lot of updates passed with update rates dependent mostly on your baud rate here, your communication link speed. And we'll stop all these. Now we're back to the normal one routine. You can see on the LED is the binary counter. All of our timing threads have stopped, and we're just getting our update value from the FPGA. So now what we're going to do is save all this data off to the computer to be used at a later time. Come down here, run Notepad, open our log text here. You can see we've got all of our processing text, which is going to be the biggest amount. Scroll through that. It's got all of our commands, all of our numeric data, all of our threads. See, we've started 3 different threads. They update in 1-second increments. Pretty tight timing. This is all rounded, but using the CPU clock, your timing can get pretty tight. Our incoming data is all logged, which is pretty much just a couple hex values. This is where we changed the value on those slide switches, and then we left it here to go on to other functionality in the program. It's our outgoing data. This is our data representing our LED routines. These are just commands 1 through 4 routines. Real simple protocol, just for example. And this is our motor speed. This is what we ended on. Since this is refreshed and overwritten, this is just going to record what we've ended on. And so that's it. This is just an example of a simple program. And so we'll hopefully have some more demonstrations to come pretty soon. Thanks a lot.